All right, here we go. Algebra 2, Unit 1, Lesson 2. We're going to kind of talk about evaluating and simplifying algebraic expressions. So one of the first things we're going to have to talk about is exponents, okay? So kind of a simple example here. If we look at an exponent, let's say negative 5 to the fourth power. Now notice that the parentheses go all around the 5 and the negative number. So this means negative 5 times negative 5 times negative 5 times negative 5. So again, if I think about this, I get negative 5 times negative 5. Negative times a negative is 25. And I do that over here as well. So I get negative 5 times, well, I could do 25 times negative 5. Okay, we'll just go down the line. 25 times negative 5 is negative 125. And I still have one more negative 5 to multiply by. And so negative times a negative gives me positive 625. So parentheses, negative 5, close parentheses to the fourth power equals 625. However, again, those parentheses matter because if I get a slightly different problem, yellow's hard to see. Let's say negative 5 to the fourth. This exponent only applies to this original number, okay? So this is like saying, hey, you have a negative 1 outside, and you're going to do 5 times 5 times 5 times 5. So we already just did. We know that 5 times 5 times 5 times 5 is 625. However, because we did not use that negative, our answer, because of that negative 1 on the outside, is really negative 625. Okay? So this exponent only applies directly to what it's above unless there's parentheses that include that negative. Okay, so let's see here. So you may have to evaluate an algebraic expression that uses exponents. Not a problem. Let's look. Negative 4x squared subtract 6x plus 11 when x equals negative 3. So notice that x equals negative 3. So you got to be very conscious about using parentheses when you plug it in. Every time I see an x, I'm going to type or plug in negative 3. So negative 4, parentheses, negative 3, close my parentheses, subtract 6, negative 3, plus 11. Always, always, always write stuff out first, okay? Before you solve it, okay? You'll make silly mistakes if you try to jump around and do too much at once. So let's look here. Negative, I got to do PEMDAS, okay? Parentheses, exponents, multiplication, division, addition, subtraction. Now, parentheses. Yes, I have parentheses, but there's nothing inside my parentheses that I can simplify. I can't simplify this. There's no like operations going on. So I'm going to check that off and move to exponents. I do have exponents. So negative 3 squared is like saying negative 3 times negative 3. So let's rewrite that as, again, haven't touched the negative 4, but I know that negative 3 times negative 3 is 9, positive 9, okay? Now, again, that's my only step I'm going to do first. I'm not going to do too many things at once. Exponents are done. Let's jump to multiplication. Do we have multiplication? You bet we do. Negative 4 times positive 9 is negative 36. And this, again, you have to remember that this negative sign is attached to this 6. So this is saying negative 6 multiplied by negative 3. And a negative times a negative is a positive 18 plus 11. So multiplication, I don't have any division. I do have addition. So let's think. Negative 36 plus 18. If I owe someone $36 and I give them $18, okay, I'm still going to owe them $18 more. So this is negative 18 by combining these two. Again, don't do too much at once. Negative 18 plus positive 11. I owe someone $18. Now I give them 11 more. I still owe them negative $7. Okay. I like to think about negative numbers as like money, but there's lots of ways to think about it. Again, you can look at the absolute value. You can say, hey, negative 36 is further away from 0 than positive 18 is. Therefore, I know that my answer is going to be negative. Another way that we sometimes like to solve problems is using words or a verbal method. So I might say, hey, I have the price per candle multiplied by the number of candles sold, and then I need to subtract my expenses. So again, if I were to put this into words, let's say that one candle cost $3, okay? So I'm gonna take my $3 candle and I'm gonna sell 75 of them. So if I take $3 and I multiply it by 75, because I sold 75 of them. However, in order to sell these, I had to rent out a booth so that I could actually get customers. And I also had to buy the materials to make the candles. So let's say that our expenses cost $120. So if I take 3 multiplied by 75, that means that I'm going to have initially $225. But I have to take away my expenses. So if I do that, I'm going to end up with a profit of $105. It's crazy. I actually have 2 friends that literally started their own candle company. And they have to kind of do this type of thinking. It's like, if I go to the farmer's market and I rent out a booth, that's going to cost me X amount of money. How many candles do I have to sell to break even? And then any additional candle after that is going to give them profit. Another thing we may have to do is simplify by combining like terms. So there's a couple ways you can do this. We'll run through a few examples here. One way might be using the distributive property. Okay, so again, that's like if you have something like 8 plus 3, and then you have x on the outside. Remember, the distributive property means anything on the outside of your parentheses, you have to multiply in. So this would be like 8x plus 3x equals 11x. Another way you could look at this is you could say 8 plus 3 is 11. 11 times x equals 11x. So again, multiple ways to look at things. You may need to group like terms together. So let's look at 5p squared plus p subtract 2p squared. Now, p squared and p are totally separate terms. So when we talk about combining like terms, you can't combine a square and a squared and then an exponent of 1, okay? So if I look at 5p squared, subtract 2p squared, what I'm gonna do is I'm gonna subtract the coefficients. So I'm gonna get 3p squared plus p. And that's all I can do. Until I know what p is, there is no way for me to simplify anything any further. Let's see here. We'll just do one last example of these. Let's say I get 3 parentheses y plus 2, subtract 4 parentheses y minus 7. Now, again, if I want to combine like terms, I'm going to have to distribute into each parentheses, okay? So I'm going to have 3 times y is 3y. 3 times 2 is 6. Don't forget this negative number is attached to this 4. Don't forget, negative 4 times y is subtract 4y. Negative 4 times negative 7 is positive 28. So if I'm talking like terms, I've got a y and I've got a y. And then if I don't have a variable, I call it a constant, but I can combine my constants. So if I look at this, I see 3y subtract 4y. That's going to be negative 1y. You don't necessarily need the 1, okay? So you could just say negative y. Either way works. And 6 plus 28 is 34. Negative y plus 34. All right, that's going to take us to the end of lesson 2.